November 18, 1943, 28,000 feet above the Hunsrück Mountains, southwest Germany. Oberleutnant Franz Stigler tightened his oxygen mask and scanned the crystalline sky, his Messerschmitt Bf 109 straining at maximum altitude. Below him, a formation of American B-17 flying fortresses droned eastward toward their target, tiny silver crosses against the winter landscape. Standard procedure said the escorts would turn back any minute now. They always did. The mathematics were simple and brutal. Allied fighters carried enough fuel to reach the German border, perhaps 50 miles inside Reich territory if they were lucky, then had to turn for home or fall from the sky. This invisible line, drawn not by generals but by physics and fuel capacity, was the Luftwaffe's greatest defensive weapon. Beyond it, the bombers flew alone. Beyond it, German fighters ruled the sky. Stigler checked his watch, calculating intercept timing, when his wingman's voice crackled urgent over the radio. Achtung! Twin-boom fighters, high, coming fast. Stigler's head snapped up. There, descending through 29,000 feet with the winter sun behind them, came a formation of P-38 Lightnings, their distinctive twin fuselage silhouette unmistakable. But that was impossible. The fuel calculations were ironclad. Lightnings could not be here, not this deep, not at this altitude, not with enough fuel remaining to fight. Yet here they were, and beneath each wing, where Stigler expected to see nothing but clean aluminum, hung teardrop-shaped tanks, silvery tubes that caught the sunlight as the American fighters dove. Drop tanks, external fuel containers. Stigler had heard rumours from pilots returning from France, dismissed reports from Luftwaffe intelligence. But seeing them here, 300 miles inside Germany, changed everything. If American fighters could reach this far and still fight, if the invisible protective line no longer existed, then the entire defensive structure of the Reich had just collapsed. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The transformation that Stigler witnessed that November morning did not begin in the sky over Germany. It began 2 years earlier, 7,000 miles away, in a series of bureaucratic meetings, engineering workshops, and desperate strategic calculations that would fundamentally alter the balance of air power in World War II. The story of how external fuel tanks turned the P-38 Lightning from a limited-range interceptor into a deep-penetration escort fighter reveals something profound about military innovation. Sometimes the most revolutionary weapon is not a gun or a bomb, but a simple metal tank bolted under a wing. The P-38 Lightning was already an engineering marvel when it entered service in 1941. Lockheed's design team, led by Hall Hibbard and a young engineer named Clarence Kelly Johnson, had created something unprecedented in American aviation. Twin Pratt and Whitney Allison V-17-10 engines mounted on twin booms, connected by a central nacelle housing the pilot and armament. 4 50 caliber machine guns and one 20mm cannon concentrated in the nose, all firing forward without propeller interference. No convergence issues, no synchronization problems, just pure, devastating firepower. The aircraft could climb to 20,000 feet in 7 minutes. It could dive at speeds approaching 500 miles per hour, and with counter-rotating propellers eliminating torque, it handled like a dream, responding to control inputs with precision that made experienced pilots grin behind their oxygen masks. But for all its brilliance, the P-38 shared the same fundamental limitation as every other fighter in the American arsenal: range. The Lightning's internal fuel capacity was 310 gallons, split between tanks in the center section and the booms. At cruise settings, burning roughly 80 gallons per hour, that gave roughly 3.5 hours of flight time. Sounds reasonable until you do the math. Takeoff and climb to altitude consumed 30 minutes of fuel. Combat maneuvering, with engines at war emergency power, tripled fuel consumption. That left perhaps 2 hours of cruise flight, meaning an operational radius of roughly 350 miles before the pilot had to turn for home or risk flaming out over enemy territory. 350 miles, Philadelphia to Boston, Los Angeles to San Francisco. In the vast expanses of the Pacific Theater, that was barely sufficient. In the strategic bombing campaign over Europe, it was catastrophic. Look at the map. American heavy bomber bases clustered in eastern England, the industrial heart of Germany, the Ruhr Valley, Schweinfurt, Berlin, lay 500 to 600 miles inland. Bomber formations desperately needed fighter escort for the entire mission. But physics said no. Fighters turned back. Bombers continued alone. Luftwaffe interceptors tore them apart. The numbers from 1943 paint a picture of systematic slaughter. In August, attacks on Schweinfurt and Regensburg cost 60 bombers shot down out of 376, dispatched, a 16% loss rate. In October, a second Schweinfurt raid lost 60 out of 291 dispatched, over 20%. At those rates, entire bomber groups would be annihilated within months. 8th Air Force Commander General Ira Eker needed his bombers protected over the target, not just to the German border. The solution seemed obvious: build fighters with longer range, but aviation engineers across America had been trying exactly that for decades, running into the same fundamental problems again and again. Fuel weighs 6 pounds per gallon. Add fuel, and you add weight. Add weight, and you need more power to maintain performance. More power burns more fuel, which means you need to add more fuel, which adds more weight. You end up in an engineering spiral where the aircraft becomes too heavy to fight effectively or too slow to catch enemy fighters. Every air force on Earth in 1943 faced this brutal equation. Japanese Zeros achieved remarkable range by stripping out armor, self-sealing fuel tanks, even radios, anything to save weight. The result was phenomenal range and disastrous vulnerability. German Bf-109s optimized for climb rate and firepower, accepting limited endurance. British Spitfires excelled in performance but couldn't escort bombers beyond the French coast. American designers tried various approaches. The P-47 Thunderbolt was essentially a radial engine with wings, powerful and tough but guzzling fuel at spectacular rates. The P-51 Mustang showed promise but wouldn't reach operational squadrons in significant numbers until 1944. The P-38 Lightning had excellent range for a fighter, but still not enough. Not nearly enough. The answer, as it turned out, was not to build the fuel capacity into the aircraft. The answer was to hang it underneath temporarily, then throw it away when empty. External drop tanks were not a new concept in 1943. The Japanese had been using them since the late 1930s. Luftwaffe fighters carried them routinely. Even American aircraft had experimented with auxiliary fuel tanks in the 1920s and 30s. But implementing drop tanks on operational fighters at scale, making them work reliably under combat conditions, and integrating them into tactical doctrine required solving dozens of engineering and logistical problems that proved far more complex than they initially appeared. The engineering challenges started with weight distribution and aerodynamics. Hang a heavy tank full of fuel under a wing, and you change the aircraft's center of gravity. The plane wants to fly nose heavy or nose light, depending on tank position. This affects handling, especially during takeoff and landing, the most dangerous phases of flight. The tanks also created drag, reducing speed and climb performance. In a fighter where every mile per hour mattered, where being 10 miles per hour slower than your opponent meant death, Adding draggy protuberances under the wings seemed like suicide. Then came the fuel feed system. The drop tank had to connect to the aircraft's fuel system, delivering fuel reliably at altitude where temperatures dropped to 40 below zero and air pressure was a fraction of sea level. The connection had to be secure enough to prevent leaks, but quick release enough that a pilot could jettison tanks in seconds when entering combat. And it had to work every time, because a malfunction meant either losing the fuel or worse, being unable to jettison the tanks when attacked. Lockheed engineers, working with Army Air Force's technical staff at Wright Field, began intensive development work on P-38 drop tank systems in early 1943. The initial designs used steel tanks, cylindrical shapes that were relatively cheap to manufacture using existing production methods. But steel tanks were heavy even when empty, and that weight cut into the fuel savings. Worse, the cylindrical shape created significant drag, especially when mounted under the wing in the high-speed airflow. The breakthrough came with a shift to aluminum construction and a more aerodynamic teardrop shape. Engineers at Lockheed's Burbank facility tested various configurations in wind tunnels, seeking the optimal compromise between capacity, drag, and structural strength. The final design settled on 300-gallon tanks, roughly doubling the Lightning's internal fuel capacity. The tanks measured 13 feet long and featured a streamlined profile that minimized turbulence. The fuel feed system used a combination of gravity and air pressure. At altitude, where outside air pressure was low, the tank pressurization system used ram air from the aircraft's forward motion to maintain pressure inside the tank, forcing fuel through the feed line into the P-38's internal tanks. The pilot controlled fuel selection with a cockpit switch, drawing from drop tanks first to preserve internal fuel until the externals were empty. A mechanical release mechanism, activated by a cockpit lever or electrical switch, allowed the pilot to jettison both tanks simultaneously. Testing revealed problems immediately. Tanks sometimes failed to feed fuel at high altitude due to vapor lock or ice formation in the feed lines. The release mechanism occasionally jammed, leaving pilots stuck with empty tanks they couldn't drop, flying into combat with hundreds of pounds of useless metal creating drag. Some tanks tumbled when released, potentially striking the aircraft's tail or causing structural damage. Each problem required redesign, more testing, more delays. But by summer 1943, the technical issues were largely resolved. Production contracts went to multiple manufacturers, not just for aluminum tanks but for pressed paper tanks, a weight-saving innovation that used compressed paper fiber impregnated with resin. These paper tanks were lighter than aluminum, nearly as strong, and cheap enough to be genuinely disposable. Engineers calculated that a P-38, equipped with two 300-gallon drop tanks, could achieve a combat radius of 700 miles, enough to escort bombers to any target in Germany and back. The logistical challenge now became manufacturing and distributing hundreds of thousands of drop tanks across multiple theaters. Each combat sortie consumed at least 2 tanks per aircraft. If a group of 48 P-38 seconds flew a mission, that was 96 tanks used, most of them jettisoned over enemy territory and never recovered. At that consumption rate, the 8th Air Force alone needed thousands of tanks per week. Supply chains had to expand. New production facilities came online. Transportation networks strained to move tanks from American factories to English airfields via convoy across U-boat-infested Atlantic shipping lanes. Meanwhile, in the Pacific, where distances dwarfed anything in Europe, drop tank development followed a parallel, but even more desperate path. The problem there was not just range, but the lack of forward bases. Island-hopping campaigns meant fighters operated from bases hundreds of miles behind the front lines. Without drop tanks, fighter coverage of amphibious landings was impossible. Japanese fighters, operating from closer bases, would slaughter transports and landing craft unopposed. Pacific Theater P-38 units began experimenting with drop tanks as early as 1942, jury-rigging systems with whatever materials were available. Some units used modified belly tanks scavenged from damaged aircraft. Others fabricated tanks from fuel drums and sheet metal, welding attachments in field workshops. The results were crude but functional, extending range enough to provide at least some coverage of advancing forces. By late 1943, standardized drop tank production caught up with demand. P-38 units in England began receiving tanks in quantity. Ground crews learned installation procedures. Pilots practiced jettison techniques. Intelligence officers briefed tactics. The transformation from theory to operational capability was complete. Now came the test. Would it work in combat? Could American fighters finally escort the bombers all the way to the target and back? And how would the Luftwaffe respond when their greatest defensive advantage, distance, suddenly vanished? The first deep penetration escort missions occurred in November 1943. P-38 groups from the 55th, 20th, and 364th Fighter Groups, equipped with drop tanks, accompanied bomber formations striking targets in western Germany. The missions were carefully planned. Fighter groups took off slightly ahead of the bombers, climbing to altitude while consuming fuel from internal tanks. As they rendezvoused with the bomber stream, pilots switched to external tanks, preserving internal fuel for the return journey and combat. The tactics required discipline. Pilots had to resist the temptation to jettison tanks too early. Each gallon from the drop tanks was a gallon of internal fuel saved, extending the escort range. But tanks created drag and reduced performance. In combat, that drag could mean the difference between catching an enemy fighter or watching it escape. Worse, if jumped by German interceptors while still carrying tanks, American pilots faced a terrible dilemma: drop the tanks and lose the range extension, or keep them and fly a sluggish, vulnerable aircraft into a turning fight. November 18, 1943. The same day Oberleutnant Stigler encountered P-38 seconds deep inside Germany, represented a watershed moment. Multiple P-38 groups penetrated beyond 500 miles, engaging Luftwaffe fighters over targets that had previously been beyond escort range. German pilots, accustomed to attacking unescorted bombers, suddenly found themselves facing fresh American fighters with fuel to fight. The psychological impact exceeded the tactical advantage. Luftwaffe pilots had based their entire defensive strategy on fuel mathematics. They knew, with absolute certainty, that American escorts had to turn back. Intelligence had calculated P-38 range down to the mile. Operational plans positioned interception points beyond escort range. The entire system depended on that invisible line in the sky where physics forced American fighters to abandon their bombers. When P-38 seconds with drop tanks crossed that line and kept coming, the certainty collapsed. German pilots started reporting encounters with escort fighters at distances they knew were impossible. Intelligence officers initially dismissed these reports as navigation errors or exaggerated combat claims, but as mission after mission brought similar accounts, Luftwaffe commanders realized something fundamental had changed. The Americans had solved the range problem. The bombers were no longer alone. The impact rippled through Luftwaffe operations with remarkable speed. By December 1943, German fighter commanders faced a strategic dilemma that had no good solution. Attack the bombers early, before they reached the target, and face fresh escort fighters with full internal fuel tanks. Wait until the escorts turned back, and the bombers had already dropped their ordnance and were heading home. Try to intercept during the bombing run itself, and fight through a screen of P-38 seconds that could now stay with the bombers all the way to the target. Major Heinz Baer, a Luftwaffe ace with over 200 victories, described the new reality in his debriefing reports from late 1943. We can no longer calculate interception points based on escort fuel. The Americans appear anywhere, at any altitude, at any distance from their bases. Our advantage of position has been neutralized. This was not the frustrated complaint of a defeated pilot. This was the cold tactical assessment of a professional, recognizing that the rules of engagement had fundamentally changed. The numbers began reflecting this shift immediately. In the last quarter of 1943, 8th Air Force bomber loss rates to enemy aircraft dropped from 12% per mission to 7% per mission. That 5% difference translated to dozens of bombers and hundreds of aircrew saved every week. More importantly, it meant bomber formations could maintain operational tempo, striking target after target without suffering catastrophic attrition that would ground entire groups for months of reconstitution. But the drop tank's greatest impact was not measured in aircraft shot down or missions completed. It was measured in hours not flown, in attacks not pressed, in ammunition not expended by Luftwaffe pilots who saw escort fighters and chose to disengage rather than fight through them. For every combat that occurred, a dozen potential combats were avoided because German pilots recognized they no longer held the tactical advantage of fighting exhausted, low-fuel opponents. General-Leutnant Adolf Galland, commander of Luftwaffe fighter forces, understood the strategic implications better than most. In his post-war memoir, he wrote that the arrival of long-range American escorts in late 1943 marked the beginning of the end for German air defense. Not because American fighters were necessarily superior in performance, the Bf-109 and FW-190 could match or exceed P-38 capabilities in certain flight regimes, but because American fighters could now be everywhere, forcing Luftwaffe units to fight at times and places chosen by the Americans, not the Germans. This represented a fundamental inversion of defensive doctrine. The defender is supposed to choose when and where to engage. The attacker must accept combat on the defender's terms or abandon the mission. But long-range escorts transformed bombers from vulnerable targets into bait, drawing Luftwaffe fighters into battles where American escorts held tactical initiative. German pilots had to engage the bombers to stop the destruction of Reich industry, but engaging meant fighting through the escorts, and the escorts could now fight anywhere over Germany. The Luftwaffe responded with typical German engineering thoroughness, attempting to restore their tactical advantage through technical innovation. Design bureaus proposed extended-range fighters, improved drop tanks for existing aircraft, even rocket-powered point defense interceptors that could reach bomber altitude in minutes but had only fuel for a single attack. None of these solutions addressed the fundamental problem. Germany was fighting a defensive war with an economy that could not match American production. Consider the mathematics of attrition. In 1943, American factories produced over 23,000 fighter aircraft. German factories produced approximately 10,000 fighters. The United States trained over 60,000 new pilots. Germany trained approximately 15,000. Even with kill ratios favoring German pilots, which they often did in individual combats, the aggregate numbers were unsustainable. America could afford to trade fighters and pilots. Germany could not. Drop tanks amplified this disparity because they were fundamentally cheap and disposable. A pressed paper drop tank cost approximately $18 to manufacture in 1943. An aluminum tank cost perhaps $50. Compare that to a complete P-38 Lightning, which cost approximately $120,000. For less than the cost of one fighter aircraft, American logistics could produce thousands of drop tanks, extending the range of the entire fighter force. German industry could not match this approach. The Reich economy, strained by fighting on multiple fronts and subjected to around-the-clock bombing, struggled to produce sufficient fighters, let alone disposable auxiliary equipment. Luftwaffe drop tanks existed, but never in the quantities needed to fundamentally extend operational range across all fighter units. The result was a widening capability gap that no amount of pilot skill or aircraft performance could overcome. By early 1944, the operational reality over Europe had shifted decisively. P-38 groups, now joined by increasing numbers of P-51 Mustangs, also equipped with drop tanks, ranged across Germany at will. The missions expanded beyond bomber escort into fighter sweeps, seeking out Luftwaffe aircraft over their own airfields, attacking during takeoff and landing when German fighters were the most vulnerable. This evolution represented another psychological blow to Luftwaffe morale. German pilots had considered their airfields sanctuaries, places where they could recover, rearm, and prepare for the next scramble without fear of attack. Now, American fighters appeared overhead during vulnerable moments. A pilot making his landing approach, gear down, flaps extended, flying slow and straight, was a sitting duck. Several Luftwaffe aces died this way, shot down within sight of their own airfield by marauding P-38 seconds that should not have had the fuel to be there. The tactical innovation extended to ground attack missions. Once bomber formations were safely on course for home, P-38 groups with fuel remaining would descend to low altitude and hunt targets of opportunity. Trains, trucks, barges, anything moving that might support the German war effort. The 50 caliber machine guns and 20mm cannon that could destroy fighters at altitude proved equally effective against thin-skinned vehicles and locomotives. German logistics networks, already strained by Allied bombing of rail yards and bridges, faced a new threat. Transportation during daylight hours became suicidal. Trains ran at night when possible. Truck convoys travelled in early morning fog or late evening twilight. Supply movements that should have taken hours stretched into days. Entire divisions sat immobile, waiting for fuel and ammunition that never arrived because the supply trains had been strafed into scrap metal by P-38 seconds that should have been 300 miles away. The operational flexibility that drop tanks provided transformed American fighter doctrine in ways that extended beyond simple range extension. Pilots learned to manage fuel as a tactical resource, calculating when to jettison tanks based on mission phase, enemy contact, and return fuel requirements. Some missions called for early jettison to maximize performance during expected combat. Others required holding tanks longer to reach distant targets, even if it meant fighting with reduced performance. This decision-making process added complexity to fighter operations, but also gave flight leaders options. A formation jumped by German fighters could jettison tanks and fight. The same formation, encountering light opposition, could retain tanks and extend range. The flexibility allowed for adaptation to fluid combat situations in ways that rigid, fixed-range planning could never accommodate. Training programs evolved to incorporate drop tank procedures. Pilots practiced jettison techniques repeatedly until they became instinctive. Ground crews drilled tank installation until they could service an entire squadron in the time it took pilots to brief a mission. Logistics officers developed supply chains that ensured adequate tank availability at every operational base. What began as an engineering solution to a range problem became an integrated system touching every aspect of fighter operations. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The technical refinements continued throughout 1944. Engineers developed improved pylon attachments that reduced drag. Better fuel feed systems eliminated vapor lock problems at extreme altitude. Standardized tank sizes allowed for interchangeability across different aircraft types, simplifying logistics and manufacturing. The pressed paper tanks, initially viewed with skepticism, proved remarkably reliable and became the standard for most operations. In the Pacific theater, where distances dwarfed European operations, drop tanks enabled missions that would have been physically impossible otherwise. The liberation of the Philippines in late 1944 required fighter cover for amphibious landings across hundreds of miles of ocean. P-38 groups, operating from bases in New Guinea and later Leyte, flew escort missions that lasted 6 to 7 hours, made possible only by carrying multiple drop tanks that were jettisoned in sequence as they emptied. The longest recorded P-38 mission of the Pacific War occurred in April 1945, when Lightning fighters escorted B-29 bombers from Iwo Jima to Japan, a round trip exceeding 1,600 miles. Pilots spent over 8 hours in cramped cockpits, managing fuel from internal tanks and 2 sets of drop tanks, navigating over featureless ocean where a navigation error meant certain death. The physical and mental endurance required for such missions was extraordinary. The fact that they succeeded routinely was testament to how thoroughly drop tank technology had been integrated into operational capability. Japanese forces, observing American fighters appearing at impossible ranges, drew their own conclusions. Intelligence reports from late 1944 show Japanese commanders accurately assessing that external fuel tanks had extended American fighter range to the point where no target in the Pacific was beyond escort coverage. This assessment influenced Japanese defensive planning, or rather, revealed how limited Japanese options had become. If American fighters could escort bombers anywhere, then Japanese forces could not concentrate air defenses at predictable interception points. They had to disperse, which diluted effectiveness, or concentrate and accept that American strikes would hit other targets unopposed. The psychological dimension extended beyond tactical calculations into the realm of morale and belief. For Luftwaffe and Japanese pilots who had trained with certain assumptions about enemy capability, the sudden expansion of American fighter range created cognitive dissonance. The world operated differently than they had been taught. The certainties that guided tactical decision-making were no longer certain. In combat, where split-second decisions meant life or death, this kind of uncertainty was corrosive. German pilot accounts from 1944 describe a pervasive sense of being outnumbered and outranged, unable to predict where American fighters would appear. The phrase, "we're finished," appears repeatedly in debriefing reports and personal letters, not as hysterical panic, but as grim recognition that the air war was lost. Skilled pilots might still achieve individual victories. Exceptional pilots might survive months of combat. But collectively, systematically, the Luftwaffe was being ground down by an opponent who could fight anywhere, any time, in numbers that made resistance futile. This demoralization fed on itself. Pilots who expected to face overwhelming odds flew defensively, seeking survival rather than victory. Defensive flying meant fewer aggressive attacks on bomber formations. Fewer attacks meant more bombers reached their targets. More successful bombing raids meant more destruction of German industrial capacity. Reduced industrial capacity meant fewer replacement fighters and less fuel. And the cycle continued, accelerating toward collapse. By mid-1944, experienced Luftwaffe pilots were being killed or captured faster than training programs could replace them. Green pilots with minimal flight hours were thrown into combat against veteran American squadrons, flying superior aircraft with unlimited fuel range. The kill ratios, once favorable to Germany, inverted dramatically. American pilots in P-38 seconds and P-51 seconds routinely achieved multiple victories per mission while suffering minimal losses. The systematic destruction of German air power was not the result of any single factor, but the drop tank was the enabling technology that made it possible. The strategic bombing campaign, which had teetered on the edge of unsustainable losses in late 1943, became an unstoppable juggernaut by spring 1944. Bomber formations struck deep into Germany with escort coverage from takeoff to landing. Loss rates dropped to levels where the campaign could be sustained indefinitely. More importantly, bomber accuracy improved because crews were not flying through walls of defensive fire from unopposed German fighters. With escorts clearing the sky, bombardiers could focus on target identification and bomb release rather than survival. The destruction of German industry, particularly synthetic fuel production, created a cascading effect that crippled Luftwaffe operations even further. By late 1944, fuel shortages grounded entire fighter wings. Experienced pilots sat idle while Allied fighters roamed German skies unopposed, not because German aircraft were unavailable, but because fuel to fly them did not exist. The bombers that destroyed those fuel refineries had reached their targets protected by fighters that should not have had the range to escort them. The drop tank had enabled the destruction of the very substance, fuel, that made air combat possible. In the Pacific, the impact was equally devastating. Japanese industry, already inferior to American production, suffered systematic destruction from B-29 raids escorted by P-38 seconds and later P-51 seconds flying from captured islands. The home islands of Japan, once beyond effective fighter range, became routine targets. Japanese interceptors rose to defend but were overwhelmed by escorts that could fight at full capability over Japanese territory. The mathematical certainty that distance provided protection evaporated. The human cost of this technological transformation was measured in thousands of Luftwaffe and Japanese pilots who died in unequal combats they could not avoid and could not win. Many were skilled aviators, trained in tactics that assumed certain limitations on enemy capability. When those limitations vanished, their tactical expertise became obsolete. They fought bravely and died anyway, victims of an attrition war where their opponents could replace losses and extend range while they could do neither. But the cost was also measured in thousands of Allied bomber crew members who survived missions that would have killed them a year earlier. Each B-17 or B-24 that made it home carried 10 men who would see their families again because P-38 escorts had been there, hundreds of miles from base, flying on fuel that should not have existed. The mathematics of war are brutal but clear. Drop tanks saved more Allied lives than they cost, and the strategic bombing campaign they enabled shortened the war by months, perhaps years. The legacy of drop tank technology extended far beyond World War II. Modern fighter aircraft routinely carry external fuel tanks for ferry flights and extended range missions. The engineering principles developed in 1943, managing center of gravity shifts, fuel feed systems at altitude, aerodynamic drag reduction, remain fundamental to military aviation. Air forces worldwide still grapple with the same trade-off between range and performance that drove drop tank development 8 decades ago. The P-38 Lightning itself was phased out of service shortly after the war ended, replaced by jets that made piston-engine fighters obsolete overnight. But during its operational lifetime from 1941 to 1945, the Lightning flew over 130,000 combat sorties, destroyed over 2,700 enemy aircraft in air combat, and thousands more on the ground. Many of those victories occurred at ranges that would have been impossible without drop tanks. The preserved P-38 seconds that appear at airshows today, their distinctive twin-boom silhouette unmistakable against the sky, rarely carry drop tanks. The tanks were disposable, temporary, meant to be jettisoned and forgotten. But their absence erases part of the story. Those gleaming restored fighters represent only half of what made them effective. The other half lies scattered across European fields and Pacific islands, tens of thousands of aluminum and pressed paper cylinders that fell from wings 7 decades ago, each one representing miles of extended range, hours of additional combat time, missions that otherwise could not have been flown. Oberleutnant Franz Stigler survived the war. He flew combat missions until Germany's surrender in May 1945, accumulating 28 confirmed victories. In post-war interviews, he spoke about the moment in November 1943 when he first saw P-38 seconds with drop tanks deep inside Germany. He described it as a turning point, not in his personal combat experience, but in his understanding of the war's trajectory. "We knew in that moment," he said, "that if the Americans could bring their fighters this far, they could bring them anywhere, and if they could bring them anywhere, we were finished." That recognition, replicated across hundreds of Luftwaffe pilots who encountered the same impossible sight, represented a psychological defeat as consequential as any tactical setback. The certainty that distance provided protection, the mathematical assurance that enemy escorts had limits, these bedrock assumptions of defensive air warfare dissolved when drop tanks turned physics into tactics and transformed theoretical range into operational reality. The story of drop tanks and the P-38 Lightning demonstrates that sometimes the most revolutionary weapon is not the most complex or the most powerful. Sometimes it is the simplest solution to a fundamental problem, executed at scale, integrated into doctrine, and deployed with the industrial capacity to make it ubiquitous. A metal tank bolted under a wing, costing less than $100, extending range by hundreds of miles, enabling